In this video, we will go over hashsets and hashes that are used with hashsets, as well as hashing in general in the world. We will also refresh our memory on tables, hash tables, and add some more on that knowledge. The code for this video and its script documentation, styled with Nimib, is in the link in the description as a form of written tutorial. Tables refresh. First off, we have already used a bit of hashing in my tables video without even knowing it. The tables module uses variants of an inefficient hash table, dictionaries in other programming languages. Here is an example. First, we import std tables. Then we make our table initialize it in this way, dot to order table, and we gave it key of type string and value of type string. The data type you use for the key and the value determines the data type for all of the other elements of this table. And here we have an example of a nested table. Simply, when you construct a table, you use the curly braces, and you do the same if you want to nest. So this means the whole table, and then this is for the value. And here is the output using the echo. Key, value, key, and value. Also note that it's nice to remember to use comma as separator for each element when they are this long to make it more readable. And here we have an example of using an object, Cobalt object, with two fields, name and string, age as integer, which will be used as the key of a table. Here we make one object of this and a second one, and then we put them inside a table. So old Cobalt, the object for the key, and then its value of fighter and mage for the second one. And here is the output. Now, if we were to try to output each of the keys of the table old Cobalt and geomaster Cobalt with a for loop, it wouldn't work, since the implicitly called items iterator does not exist for objects inside a table. The following code will not compile. Now, this can be solved in two ways. The first way is kind of messy, and it involves some boilerplate code to overload the items iterator, as well as the hash proc from the hashes module, which is used to hash the value into a more performant value. This messy way, as well as a lot of details on what hashing is, etc. later. Now, the clean and easy solution is to use the keys iterator specifically made for tables, like this. For Cobalt in Cobalt table.keys, and we output, and it goes with every key. And since every key is an object, we get its fields, name goldtooth, age 31, etc. Now, this code only outputs the actual keys of our table. In order to get the values associated with those keys, we must insert those keys back into our table with the index axis of square brackets. So, the exact same as above, but then in square brackets, Cobalt. And then we get the values, fighter and mage. There is also the values iterator, amongst others for tables. This iterator will go through all of the values of a table, just like how the keys iterator went through all of the keys. With this iterator, we then don't have to insert the key back into our table to get the value when iterating over the entire table like this. I believe I have never shown that you can also use multiple variables for capturing data in a for loop. So let's do that with the pairs iterator. So instead of just key, we use a comma and use another one. And then pairs. And then you echo key and value. And then we get this output and the value. The pairs iterator can also be used for when you want to capture the index when iterating over the elements of a container like so. For pause position, element in hello world.pairs, echo pause and element. So 0h, 1e, etc. What is hashing? Hashing is the process of transforming any given key or string into a usually another shorter and more efficient value by the use of a one-way mathematical hashing algorithm function. One-way algorithms are used because hashes are also used for encrypting data, and a two-way algorithm would fail that. The most popular use for hashing is the usage of hash tables. A hash table stores key and value pairs in a list that is accessible through its index. Because key and value pairs are unlimited, the hash function will map the keys to the table size. A hash value then becomes the index for a specific element. Hashing is used in data indexing and retrieval, digital signatures, cybersecurity, and cryptography. They are also used on some websites, especially those dedicated to Linux operating systems, distros, and programs, to check your checksum secure hash algorithm SHA message digest functions MD against the one on their website to ensure it is exactly the same without any tampering by a malicious person. There are several modules in NIM for dealing with hash function algorithms. NIM will install checksum before use of the SHA and MD5 modules. SHA-1, old and used for legacy purposes mostly. SHA-2, newer, but still mostly used for legacy purposes, not enough for data security. And SHA-3, newest, use this one. And also MD5 and base 64 for encoding and decoding data, which you can't with these, as they're used for hashing, one-way algorithms. The usage of hashing in data structure is used for the reasons of speed. That speed is due to the fact that value is much smaller once hashed, and also because hashed keys are mapped to the size of the table, which serves as an index to quickly find the desired data, without the use of loops, which can take much longer to find the data. There is a phenomenon called collision, which is when two or more hashes manage to generate an identical hash. Different hash functions have different margin of collisions. To address this, there are methods like double hashing, linear probing, quadratic probing, and separate chaining. In cybersecurity, they can go a step further with the term salting, which is adding random data into the hash function. It helps with attackers from accessing non-unique passwords by the use of rainbow tables. Reverse engineer data. Hashing in NIM. You can hash just about any data type in NIM. There is no list of what you can, but mostly everything. You can easily hash your own data types, but first you must use a bit of skeleton code, boilerplate code, to do so. The following two examples are taken from the hashes module page that are required for your own data types. Both of the examples are slightly renamed, with the first no longer overloading the items iterator from the implicitly imported system module in order to avoid the items iterator from being used implicitly for yielding hashed values. Remember, the items iterator is the one called by default implicitly, invisibly, in a for loop when not specifying the iterator, like this. And Visual Studio Code extension for NIM will tell you, like this. So this is the same as this, just explicitly calling it instead of implicitly. Example 1, boilerplate code without using the implicitly called by default items iterator. First off, we import the hashes module from the std, and then we make our object over here. Then a custom iterator, we give it argument of our object, and then it just yields the hashed value of our fields, so foo and bar. And here is this hash proc we are yielding over here in this iterator, specifically made for our custom object. This variable will return the hash, and here we loop through all of the fields, and then it mixes all of these fields, and then it finalizes and gives us the hashed value. Here is an example of using the above boilerplate code. So first we make an object of custom object type, then a for loop, and we call hashed fields iterator that we made for our custom object that will then echo each of the fields. And here is the hashed value for each of them, the fields. If your custom types contain fields for which there already is a hash proc, you can simply hash together the hash values of the individual fields. No need for the overload of the items iterator. So here is the example, simply named custom object 2, no custom iterator, and then for the same exact reason, no for loop. So instead just use this return variable and mix the first field of foo and then the second one and finalize. And here's the example of using this. Simply using an echo custom object 2 and hash, and here is the resulting hashed value. Now, the reason there is only one hashed value here is because this is the entire object hashed, while up above it's each of the fields. So 2 fields equals 2 hashed values versus an entire object. Hashing ref objects. First off, I'm going to show you what happens if you try to use a ref object for the key of a table. So required imports, tables and hashes are ref object. And here is the sample code using this ref object, which will error because of init table of type ref cobalt string, which doesn't work with ref objects. It crashes immediately on any attempt of setting a ref object's fields to anything. So let's do what we did so far without the use of init table, but with direct initialization. So curly braces, inside we have key value elements to order the table. So no init table, just curly braces with our key values. And if we try to run this code, we get the following error. Larger picture here. This error can be easily fixed by using the following compiler configuration parameter with a config.nims config file, the nim preview hashref. This configuration parameter allows for hashing of ref objects and will likely be used by default in future versions. Do note that we haven't actually hashed the key ref cobalt yet, and now that the above code works using the dnim preview hashref, here is some code to use the keys, values, and pairs iterators to see if they still work, and they do. With a slight change, the first one requires dereferencing for the key since it's now a ref object, and the same goes for the pairs iterator. So the first key needs dereferencing, value obviously not. Now, even though it appears that we don't need any boilerplate code to make this work, again, hashed values are much more performant than their non-hashed counterparts. This is especially true for objects, which are often quite numerous in fields which can contain other containers and other objects, structures. And quick reminder, echo and the implicitly called items iterator do not work with objects as keys inside tables. Also, do not overload the implicitly called by default items iterator. Now let's hash our ref object of ref cobalt. First, let's bring the above boilerplate code and modify it to ref cobalt 1, as in example 1, as arguments of the custom hashed fields iterator and the hashproc overload. So this will change. Iterator hashed fields will go from cobalt to ref cobalt 1, and the proc of hash cobalt, and then into ref cobalt 1, like so. Ref cobalt 1, ref cobalt 1. And here is the code using the boilerplate code above, same as before, just renamed. And then this got changed a bit from example 1, because previously we only had an object to loop through, like so, object. But now this object, 2 of them, are inside a table. So the loop has to go through key and its value. And then we have to use another loop to go inside that keys, which is an object, to get the fields. So for field in key.hashedFields, our custom iterator to make this work, and then we echo. And then we get each of the fields hashed for first object and the second. And now the example2 boilerplate code renamed for our ref object. So no iterator, just the hash for its fields, first field and the second. Then our two kobolds, and then the table, and then we loop like before with the pairs. This one just a bit more stylish than the first one. So the key hashed and value fighter non-hashed, and for the second one. All variants of tables and some use cases. In this video, I have introduced you to the ordered table besides the normal unordered one from the tables video. There is also the count table for mapping from a key to its number of occurrences. And lastly, there are ref reference versions of each, with ref affixed appended at the end like so. Table ref instead of table, ordered table ref, and count table ref. In case it wasn't clear on when to use tables, hashTables in Nim, here are a few examples, use cases. Whenever you have two pieces of data that you want linked together, e.g. your phone contacts, name and number, games music listings on your computer, name of the game, music as key, and value as location. When generating JSON, lightweight data interchange format, before it gets stringified, it's represented as a table, dictionary, or a lookup table, and nested tables. Here is an example of what we did before, making a table and hashing one of its keys, then reinserting that hashed value back into it. So the first key getting hashed will get us this hashed value, and then reinserting it back will get us the value of 1. And now lastly, I will show you a very useful proc for tables called mget or put. Mget or put retrieves the value of a specified key, or inserts puts a key value pair into the table if that key value pair is not present, and then returns back the value of that key in a modifiable state. So here is a table with A of string as its key, 1 for its value, B for its second key, 4 for its value. And then we use the mget or put on it, A key, and then 10. This is used if this key and its value wouldn't exist, then it would insert into our table A10. But since it does exist, we instead get the value of 1 back into it. Same with the second one. For B key, we get 4. And then lastly, since C key is not in the table, it gets inserted into it with the value of 10, like so. Now, that modifiable state of the value can easily be accidentally used to create a copy of the value instead of modifying it. This is the case when trying to use this mget or put proc with sequences and strings, which are value types by design, meaning that they cannot be copied into a different variable and then use that variable to modify the value of a given key from the table. This is mostly for people coming from other programming languages where sequences and strings are passed by reference. Also note, if you see procs or iterators starting with the letter M, as in mget or put or mItems, it means that their returned value is modifiable. For example, when using the items normal one iterator, you can only use that iterator to loop through some fields, elements. But if you use the mItems one, you can change those. Here is an example of what not to do. So first, we make a new table with integer for its key data type and sequence of type integer for its value. Then we make a new variable, copied table, and into it give our new table with first key of 10 and sequence of 10 as its value. And then if we try to give this copy table 20, it would only give this 20 to its sequence to the copy table and not our declared table. As you can see, our original table is unchanged. Again, this is because strings and sequences in Nim are passed by value, while in most other programming languages they are by reference, meaning that if this declared table would be passed by reference, so making another table have the value of declared table, both would change when you would modify one of them, not in M. And now lastly for tables, since the value returned by mget or put proc is modifiable, you can do the following. Mget or put for key 10, sequence 10, you can then .add 50, and this will give 50 to the sequence of the value. Hash sets. First off, hash sets are allocated on the heap. Now let's make the simplest hash set data type a normal set cannot use. String. We cannot declare an empty hash set, it can only be initialized. So this example is just for show, since every hash set is always initialized in this same way by default anyways. We're going to need the sets module for all the hash sets. So here's the initialized version, square brackets like with arrays, but then 2 hash sets. And here's our string type hash set. Note that the order of the elements is unordered, not the value of an element. Now let's have a look on how hash sets and hash tables look like in procs. So hash set is simply hash set with capital letters and then the return, simple. Tables, the same, but you can also do them like this, an initialized version. So the variable argument for the proc and then give it value of a table. Here we call all these 3 procs. There is an additional operation you can do with the hash sets that you cannot do with normal sets, which is symmetric difference set1, set2. Minus plus minus is the alias for that proc. This proc gives you only the elements that are not present in both sets at the same time. So, for example, you have a set A with A and B char, and set B with B and C char. So, B is in both of them, A and C are not. So, A and C will get returned. And here is another example of this symmetric difference. So, here we have 2 sets, and they have tuples for the data type of their elements. And so, the first one has key 1, 10 for the first element, then key 2, 20. The second set has key 2, 20, and key 3, 30. So these 2 are the same, while these are not in either of them. So using symmetric difference, we get key 3, 30, key 1, 10. There is also this joint, set1, set2, which returns true if the sets S1 and S2 have no items in common. So both of them have 1 and 2, so it returns false. They do have elements in common. Then we have missing or exclude, S key, which excludes a key first and then tells you if the key was already missing from S. So here's a set, 1, 2, 3, 4, 5, and then we check with missing or exclude for 1. So it excludes it, but since it wasn't missing, we get false. And then when we run it again, and since the previous one excluded 1, now we get true. Then we have contains or includes S key, which includes a key in the set S and then tells you if the key was already in S, inverse of missing or exclude. So our set 1, 2, 3, 4, 5 contains or includes 6, but 6 in it. And then with the if and echo, we check if it's already in it. And since obviously it's not, it's gonna output this, so this. And then we run the exact same code again, and we get the reverse. We also have the map data op proc for these sets, which returns a new set after applying op, being anonymous proc on each of the elements of data set. And here's an example of this. So our set, which has 1, 2, 3, which are integers, and then we store into b variable a.map, and we give it the structure of this proc, return type of string, and we just use the $sign to turn it into a string. And so 123 becomes 123 in string. And here is my example at this proc. First we have a set with lowercase and uppercase, lowercase l and uppercase u for the set. And then based on this set, we construct two new sets. The first one goes through all the elements and checks every letter char if it's lower ASCII, and if it is the whole element, then it puts those elements, so this one and this one, into its set. And for the second one, uppercase u. So set new l is all lowercase, and the second one is all uppercase. The default return value of a proc returning string is an empty string, so that's why we have these two empty strings here. And then we also have clear s, which clears the hash set back to an empty state without shrinking any of the existing storage. So here we have some size set 1, 2, 3, 4, 5 string. We copy it into copied set, then we clear it, and the result is still 24 bytes, just like at the beginning. Then we have pop s proc, which removes and returns an element from the set s. You can specify which element to pop. Here's some sample code that shows how it works. So here we have a set ABC, pop once, twice, third. So the first time is going to be A and removes it, and then B and removes it, and then C. And now the set is empty. There is a use case for the pop proc. For example, if you have a pool of jobs to be done in no particular order, let's say that on weekends you clean your room, do your laundry, change the sheets, etc. That job only requires to be done once. So you would use a do the job, process job proc that would pop a job from your pool of jobs and then execute it. Once all the jobs are done, you can put the exact same ones back in when weekend comes or some relatives are coming to visit. Here's an example. Here is a simple prop, execute job, which takes a string and just outputs the job you're doing and that it's finished. Here's the jobs in a hash set, and then while there are jobs, we pop the job and execute it. And lastly, square brackets, which returns the element that is actually stored in hashSet, which has the same value as key, or raises the key error exception. This is useful when one overloaded the hash proc and the equals operator, but still needs reference semantics for sharing. hashSet use cases. One of the hashSet use cases is very similar to the last use case example of the previous video of normal sets. The example being splitting a string based on character elements as separators. With hashSets, we can go a step further. We can use whole words as separators. So let's use the split proc we made in the last tutorial and update it for string hashSets. We're also going to add another argument of type bool to tell the proc if we are working with set char or hashSet string. Currently, the compiler cannot infer which to use since the second argument of seps is not an argument we can give, since it is already initialized. So as a reminder from the previous video, here are the separators, empty space, exclamation mark, and question mark. And here is the string we're going to use the separators on. So it's going to remove these, and here's the actual output. And here is the modified version. This part is for the normal set from the previous video with separators in here because we can't put them in here anymore. And here is the second added part so that this proc split works with strings as separators as well. So how does this work? First, we define the separators as a hashSet. Then we put the argument we got into split string, and C will be used for the location of the separator we're going to find. So here C takes the location from our string that we're using. And then if the location, for example, var, if this plus the length of this var is less than the actual length of the string we give it, so that we don't accidentally try to delete from over the size of the string, which would be an error. And then we delete from that location to the end of the separator. And this repeats for all the separators, and we get this result from this one. Quick re-explanation of hashing. In case I did not explain or convey this information well, hashing a value with the hash proc lowercase h returns a value of type hash with an uppercase h, which allows for containers such as arrays, sequences, sets, hashsets, etc., which only allow for a single data type to be used, to instead store just about any data type you want. Obviously, this also works for variables and structures such as objects, tuples, etc. Hash values must be available for any type that you want to use as a key in a so-called table data structure, and also again for hashing of usually complex and large structures such as objects, and obviously tables implemented in such a way for the reasons of speed. Tables are also often called dictionaries or lookup tables. Okay, that's it for this video. Thanks for watching. Like, share, and subscribe, as well as click the bell icon if you liked it. And one more. You can also follow me on Twitter of the same name and support me on Patreon. If you had any problems with any part of the video, let me know in the comment section. The code of this video, script, and documentation are in the link in the description. Is a form of written tutorial.